All right, so with this problem, we know a few things. What all do we know? We know the mass of the diver. We know the height of the high dive that he is on. And is there any other important information? There's no drag. So we're not going to lose any energy to friction or anything like that. So let's go ahead and make sure that we write that information down. So we know the mass of the diver is equal to 98 kilograms. Correct? We also know that the height that he is going to fall from is 5.5 meters, correct? All right. Okay, so our first problem is asking how much kinetic energy does the diver have basically at the bottom? Correct? How much kinetic energy does the diver have just before he hits the water? In order for him to gain kinetic energy, that energy has to come from somewhere. Where is that energy going to come from? The potential energy that he has at the top of the high dive. Now, how does he gain that energy? He applies a force, moves himself a distance up the ladder, and as he applies that force and climbs that ladder, he is gaining potential energy through the work he is doing. Once he's at the top of the high dive, so I'm going to draw a little picture here just to kind of help get this, and my drawing skills are terrible, so just bear with me. So here, no, we're going to not do that. All right, so here's our high dive. So he climbs up the ladder, does work, and then here's our little guy standing at the top, and he's about to jump down. And then here's our pool at the bottom. All right, so there's our pool. And it's a really, I don't know. Yeah, it's a kiddie pool from 5.5 meters, which is roughly about 15 feet. Or no, it's about 20 feet. So that's really tall. Okay, so remember, he's going to fall down. And as he goes down, his energy is going to transform from kinetic to potential. So the main idea here that you have to understand in order to answer this problem is up here, we have all potential energy. So the potential energy at the top is the whole total energy. There's no kinetic. Okay, pause. So the potential energy at the top is all the kinetic. Is all the energy, because at the top, hang on. There you go. Thank you. There is no kinetic energy at the top because he's not moving. So there's no kinetic energy at the top. Now at the bottom, the total energy at the bottom is going to be equal to what kind? All kinetic. Because at the bottom, there is no potential. So the big idea here that you have to understand in order to begin to answer this problem is, in this situation, the potential energy at the top is equal to the kinetic energy at the bottom. In this situation, because you were not moving at the top, your kinetic energy at the bottom is equal to the potential energy at the top, because the total energy never changes.
But in order to dive, don't you have to go up?
Well, he did work because he applied a force to go up. He applied a force over a distance. He gained energy that way. When he's just at the top, he's just going to fall. Gravity is going to do the work on him and apply that force over a distance and cause his energy to change.
So if we got a question saying, like, what's the potential energy at the bottom?
Yes, so the question was, is the potential energy at the bottom 0? Yes, because you have no height. So in order to calculate this, I know I can calculate my potential energy at the top. So this is at the top. This is going to be equal to mass times gravity, or the acceleration due to gravity times your height. So you would have 98 times 9.8 times a height of 5.5. And that is your potential energy at the top, which comes out to be 98 times 9.8 times 5.5 is equal to 5,282.2 joules. That is how much total energy he has at the top. That is his potential energy at the top, which, remember, is also equal to the kinetic at the bottom. Hi, Matthew. Okay, so looking for the velocity just before he hits the water. So you're looking for the final velocity. We know that the kinetic energy at the bottom is equal to, oh, no, not that, 5,282.2 joules, correct? So if I wanted to find the kinetic energy, I know that, or if I need to find velocity and I know kinetic energy and I know mass, I can use my kinetic energy equation, correct? I know the kinetic energy, I know the mass, and it has my unknown in there. So I would have 5,282.2 is equal to 1/2 times the mass of 98 times v squared, and I'm looking for v. A tip when it comes to using this formula in the calculator, instead of trying to do 1 divided by 2 or putting 1/2 in your calculator, a better option is 0.5. A lot of times when y'all go using fractions, you think you're telling the calculator one thing, but it's understanding something else with the division. So I would highly recommend using 0.5 instead of 1/2. So you can go ahead and multiply if you want 0.5 times 9.8 or times 98, and that gives you 49. So then you would divide both sides by 49. 5,282.2 divided by 49, and I get 107.8 equals v squared. And a lot of you will stop here. The most common mistake in this, the most common algebraic mistake is you would have stopped. Am I really done with my problem?
No.
I am not. What do I need to do? I need to take the square root. So I take the square root of both sides. And so the final velocity is 10.38 meters per second.